Okay, so question number 9, 4.2, pre-calculus 30 says this, important for you to know. Use the diagram below to help answer these questions. All right, what is the equation of this circle? All right, so we talked a little bit about equations of circles. Remember, the equations for a circle is x squared plus y squared equals r squared. Now, r would be the radius. And so what is the radius of this circle? How can you tell? What are we given? Well, we're given one point right here, this point right here, A. And so the radius, because the x value is 1, the radius is 1. So for A, the equation of the circle is x squared plus y squared equals 1 squared, which 1 squared is just 1. So it looks like A should be x squared plus y squared equals 1. Okay? Unit circle equation. Is that good? All right. B, if the coordinates of C were negative 2/3 and root 5 over 3. Now you may think, I haven't seen that on the unit circle. I don't know what significance those hold. Doesn't really matter. The coordinates are for this point right here. So negative 2/3 and root 5 over 3. Okay, I'll just jot them down there. And it says, what are the coordinates of B then? Okay, so B and C are related here because there's a 90-degree angle here, if you can see that. Okay? Now, I might zoom in just a little bit here because I do want to work on this diagram. So what does that mean? Well, if you recall when we were learning the unit circle, there are some connections between points on the circles, right? When they make rectangles. And the reason why there's those connections, and so I could make a connection over here. Well, that doesn't help us. I could make a connection over here. Nah, that doesn't really help us either. But if you notice these triangles that I'm going to draw. So look at this triangle right here. This is a right triangle, right? And so is this. Right triangle. Now this has the coordinates, or distance, 2/3 right down here, this base. The height is root 5 over 3. And if they're related by a 90-degree angle, okay, so really this quadrant, like if you flipped this triangle over so it looked kind of like this, it would be like a symmetrical sort of fan wheel, right? So just bear with me for a second. Do you see how that's the same as that one? I just flipped it over. No, maybe not. Okay. If they're related by a 90-degree angle, then what happens is that this long side here is the same as this long side over here, and this short side is the same as the short side. If we look to our unit circle, so I'm going to pop over the unit circle here. Just take 60 degrees for example. Okay, 60 degrees, when you add 90, you get what? 150. See that? So in between these two arms would be pretty similar to what we're looking at on that question. And so how are these related? We know there's a difference of 90 degrees here. How are they related? Look at the points. 1/2 root 3 over 2. Over here, it's negative root 3 over 2, 1/2. So these are identical triangles. They're just oriented a little bit differently. All right, so you see that, how this is the triangle that we have in the question, and then this is the triangle that we have in the question. Okay, and so if they're separated by 90 degrees, you know there's a relationship with their side lengths. So if we go back to our notes here, this relationship holds true. They're really identical. Okay, so going back to that question, if these are the coordinates, what are the coordinates of B? Well, positive root 5 over 3 and positive 2/3 should be your answer, I think, there for B. So for coordinates of B would be root 5 over 3 and positive 2/3. Does that look correct? Everybody agree with that? All right, let's move to C then. If the measure of arc, now remember this is the symbol for arc. I don't know if I've explicitly told you that, but if you had to guess, or if you ran into this when you were doing your assignment, you say, I've never seen that before, Mr. Maxwell missed that. It's possible, but guess what? There would be some examples that have that. You'd be able to connect arc AB with that symbol in the examples in your textbook. So it is still important because I don't go through every single example. That would take me the full hour of class that we have. You would have no chance to work on any work here on your own, and I don't really want to talk for a full hour and not give you a chance to work through things while you're with me. So some of the examples, some of the notation, if I perchance happen to miss it in a lecture, you just have to look back into your textbook, okay? Look back to the examples. But anyways, this is arc AB. So if the measure of arc AB is theta, so let's see, let's erase some of this now. So arc AB, where is that? That would be right here. That arc AB, that's theta. It also means that this is theta, doesn't it? Okay? Because we're at a unit circle, right? And the radius and the arc length are related in a unit circle, aren't they? So they're going to be the same. What is an expression for the measure of arc AC? So we're looking for arc AC now. Well, what do we know about that? Okay, well, we have arc AB, and then it looks like we have plus 90 degrees here. What is 90 degrees when we're talking about radians? What's 90 degrees in radians? Pi over 2, because pi radians is 180, pi over 2 is 90. So how could we express this angle measure, AC? Arc, sorry, not angle measure, but arc length, AC. What would you say? Theta, which is AB, plus what? Right. Okay. Now, you could have also done this. Maybe you said, hey, this is 180 minus theta. Does that make sense? 180 minus theta, or 180 minus 90, or what would it be if you took a look at pi? Could you write it in terms of pi? Might be a little tough, eh? So I don't know if you need to do this, but could we figure out what this was? Theta. This is 90. What's this? Yeah, this would be pi minus pi plus, minus theta plus pi over 2, right? So this right here, yeah, and I probably wouldn't suggest doing this, but this right here, this little dot, okay, this is an aside, this little dot, this angle, or this right here, c to pi here, that would be pi minus theta, get rid of this, minus another theta over 2. Does that make sense? Okay, so you don't need that. This is the right answer for C. All right, D, let P of theta be equal to B. Okay, so the point of theta here, so is B. We have that already. In which quadrant is the point theta minus pi over 2? So they're saying if this is theta, right, where is theta minus pi over 2? So theta plus pi over 2 would go this way, right? That's plus, but this would be minus. So what quadrant does it end up in here? Yeah, it should be quadrant 4. And you could say 4, but you should get into the habit of using the Roman numerals there, I, V sort of thing. Okay, it's quadrant 4. And then E, what are the maximum and minimum values for either the x coordinates or the y coordinates of points on the unit circle? The maximum values, well, if we're talking about maximum values, we're talking about how high does the circle go up the y, and how far does it go along the x, maximum, minimum, and so on. And so I guess for the unit circle, right, y max is positive 1, y min is negative 1, and so on. X max is 1, x min is negative 1. Okay, and that looks like E. Okay, does that look right? Is everybody okay with that? Does that answer some questions there for number 9? Let's move on to 4.3.